get the total resistance. So our total is just the sum of all resistances. So we have R1 plus R2 plus R3. And we have R1 is equal to 10 ohms. We have R2 equals 20 ohms. And we have R3 is equals to 30 ohms. So we have 10 plus 20 is 30 plus 30, so that would be 60 ohms. So the R total is equal to 60 ohms. Current I. So current, so we know that from the Ohm's law, where voltage is equals to IR. So we have voltage. We also have the total resistance, the 60 ohms. So we can get the current. So current is equal to voltage over the resistance. And we know that voltage is 12 volts. And the total resistance is 60 ohms. So current is equal to 12 volts divided by 60 ohms. So we have 0.2 ampere, and also denote it as 0.2, and then move to the 3 places. So we have now 200 times 10. So we move 3. The decimal places move 3 times to the right. So we have here times 10 to the negative 3 ampere, or it is also equal to 200 milliampere. So we have current is equals to 200 milliampere. Next is the voltage drop in each resistor. So we get the current as equal to 200 milliampere. Now let's solve the voltage drop in each resistor. So we have the current and we have the resistance. So again, current is the same through all as it passes through the resistance 1, resistor 2, and the resistor 3. So voltage is equals to current multiplied by resistance. So at voltage in the resistor 1 is equal to the current is 200 milliampere multiplied by the resistance is 10 ohms. So that is 2 volts. So we have V1 is equal to 2 volts. Next, we have the at V2, or the voltage drop in resistor 2 is equal to current multiplied by resistance. Current is 200 milliampere and resistance is 20 ohms. So the voltage drop in resistor 2 is equal to 200 milliampere multiplied by 20 ohms is equal to 4 volts. Next is the voltage drop at resistor 3. At voltage drop in resistor 3 is equals to current multiplied by resistance. And current is equal to 200 milliampere multiplied by its resistance is 30 ohms. So we have 30 ohms. So we get, so voltage drop in resistor 3 is equal to 200 milliampere multiplied by 30 ohms is 6 volts. And now we got that the answers are the total resistance is equal to 60 ohms and the current is equal to 200 milliamperes, and the voltage drops in each resistor. So the in resistor 1, the voltage drop is 2 volts. The voltage drop in resistor 2 is 4 volts, and the voltage drop in resistor 3 is 6 volts. Now let's talk about power in series. The total power in a series circuit, we found that Ohm's law could be used for total values in a series circuit, as well as for individual parts of the circuit. Similarly, the formula for power may be used for total values, which is power total denoted as P subscript is T is equal to current multiplied by the total voltage. So the current is in ampere and the total voltage is in volts. The total power produced by the source in a series circuit can also be expressed as the sum of the individual powers used in each part of the circuit. So we have the total power is equal to the power dissipated in load 1, power dissipated in load 2, and so on. So the total power in watts, and the P1 is denoted as the power used in first part, and P2 is for the second part, and so on. So example for solving problem in power dissipated in a circuit. So in a circuit shown in figure, we have a 60 volts voltage source. We have the current I in this direction. We have a resistor value 5 ohms and resistor 2 value is 10 ohms. So we know that the formula for power is equals to voltage multiplied by its current. So and then we have here the voltage, but we don't know the current. So we need to find first the current. So in finding the current, according to Ohm's law, where voltage is equals to current multiplied by resistance, is that current is just equal to voltage divided by the resistance. So we have here the voltage, but we don't know yet the value of the resistance. So we got to find the R. So we have here R total is equal to R1 plus R2. So we have 5 ohms plus 10 ohms. So that would be 15 ohms. So we have now the R. So we get current is equal to voltage is 60 volts over the total resistance, which is 15 ohms. So that would be equal to 60 divided by 15. So we got here 4 ampere. So we have current now, which is 4 ampere. And now we need to find the power total by each resistance. So we have here current, and we only need the voltage drop for each resistance. So we have power is equals to VI. So if power dissipated at R1, so we have power 1 is equal to V1 I1. And we already have the current, which is 4 ampere. And the voltage is not yet, so we need to find the voltage first. So V1 is equals to I1 multiplied by R1. So we have current is equals to 4 ampere multiplied by the resistance is 5 ohms. So we get voltage as equal to 20 volts. So we have now the voltage for the resistor 1, and we also get the voltage 2. So we have 4 ampere multiplied by resistor 2, which is 10 ohms. So we got 40 volts. So we have V2 is equals to 40 volts. Now we already have the current, and we already have the voltage drop for each resistance. So we can now solve the power dissipated in each resistor. So we have power is equals to V1 I1. So we have V1 as 20 volts multiplied by current, which is 4 ampere. So that would be 80 watts. So power dissipated in resistor 1 is 80 watts. Next, the power dissipated in resistor 2. So we have V2 I2. So the voltage is 40 volts multiplied by the current of 4 ampere. So we have 40 volts multiplied by 4 ampere is equal to 160 watts for power dissipated in resistor 2. So we get the power total. is equals to power 1 plus power 2. We have here 80 watts plus 160 watts. So we have total of 80 plus 60. So we have 0 and then carry 4. So 1. So that will be 240. So we have 240 watts. So the total power dissipated in each resistance or resistors is 240 watts. Now let's there are other ways in solving the total power dissipated by using the given current and the resistance. So let's try using power is equal to VI, right? And we know that voltage is equal to IR, right? So we have IR multiplied by I. So we get power is equals to I squared R. So we can also use this formula because we already get the current, which is 4 ampere, and we also have the value of each resistance. So let's try using this one, and if we're still gonna get the same answer. So let's try. So in case we haven't go directly to solve the voltage drops in its resistors. So let's try. So we have power 1 is equals to I squared R. So 1 and 1. So we know that currents in series circuit, they have the same. So the currents from the source and the current that passes through the resistor 1 and resistor 2 is the same. So we have here current is equal to 4 ampere. So we have squared. The resistance is 5 ohms. So we have now 4 ampere 4 ampere squared, that would be 16 multiplied by 5. So that would be 80. So the unit is watts. So we have the power at the resistor 1 dissipated is 80 watts. So let's try finding P2. So we have I2 squared R2. So we have current, the same. 4 ampere squared multiplied by resistor 2 is 10 ohms. So we have 4 squared, that would be 16 multiplied by 10, we have 160 watts. So at P2, we get 160 watts. So again, total power is equals to P1 plus P2. So we have 80 watts plus 160 watts. And again, that would be 0, 6 plus 8, that would be 14, so 240 watts. So the total power is, we get 240 watts, which is also the same as what we get from the other formula. So again, any of the formulas, you may use the I squared R or the power is equals to voltage I. It's the same because you will still get the same answer. So any of the formulas, we get the current as equal to 4 ampere. We also get the power dissipated in each resistor as 80 watts and 160 watts. And the total power dissipated by resistor 1 and resistor 2 is equal to 240 watts. So next, we have the polarity of voltage drop. So the polarity of the voltage drop is determined by the direction of conventional current from positive to a more negative potential. So again, conventional current starts with the positive to the negative. So the nearer to the positive terminal of the voltage source is more positive, while the point nearer to the negative terminal of the applied voltage is more negative. So to draw the positive and negative in each resistor, so we the conventional current again is from the positive to negative. So here we have here more negative, so that will be positive, and then negative, and then positive and negative. So let's try. So we have here, this is for the positive. When you have a circuit that the voltage source looks like this, because it represents battery, or some others they put cells, just two, but here we have your battery, so we have here 95 volts for source. So this is positive and this is negative. The longer horizontal line is the positive, and the shorter is the negative. So we have your positive, so the resistor near to the more positive part will be the positive side. And then positive, negative, and we have your positive and the negative. So again, you can't put the two end terminals of the loads that like for example, we have your negative, and then you put the load terminal negative of the next load in the here. So again, that's not possible because it will short, and basically it will ruin your circuit, it will burn. So be mindful with that one. So we have here the voltage 1, voltage 2, and voltage 3. The voltage drops of the loads here in the circuit. And then we have here the voltage applied, or the applied voltage is 95 volts. And the voltage drop in B is 85 volts, and the voltage in C is 60 volts, while the voltage drop in D is 0 volts. So here, the voltage is 95, and as the current passes through here, the voltage in the point B is now 85, and as it passes through this load, the voltage in point C would be 60, and the voltage in D is 0. Next, we have here a problem. So solve the following. We have here a circuit that has a total voltage of 18 volts, and we have here three loads. So we have here resistor 1, resistor 2, and resistor 3. So solve the voltage drop in A to G, and the voltage drop from V to G, and the voltage drop of C to G. And next, we also have here a problem number 2. So we have here a resistor of 45 ohms and a bell of 60 ohms are connected in series as shown. What voltage is required across this combination to produce a current of 0.3 ampere? We also have another problem, which is we have here the circuit. So a 95 volts battery is connected in series with 3 resistors. So we have 20 ohms. We have a resistor 2 as 50 ohms, and we have the resistor 3 as 120 ohms. Find the voltage across each resistor.